here again today. Today we are going to be talking about equations of motion. We already know what motion is by now. Motion is simply the change in position of an object. The change in position of an object. However, today we are going to be talking about equations of motions. Okay? Now let's assume a body moving from rest. Okay? With a velocity u in meter per second. Accelerates suddenly with acceleration a in meter per second squared, okay, at a particular time t in seconds. Then it reaches a final velocity v in meter per second. Now with all this information, we can then say that our acceleration is equal to change in velocity all over time interval, If we further break this down, we can say that this is the same thing as what? Final velocity minus initial velocity, okay, all over the time interval. Now if we use alphabets to represent this words, this information we put in words, we have a is equal to v minus u over t, where a is acceleration, v is final velocity, u is initial velocity, and t is time taken. Now the first equation of motion is derived from the formula of acceleration. So if we cross multiply, we have at is equal to v minus u. If we cross multiply, we have at is equal to v minus u. Okay, now if we make v the subject of the formula, or simply put, we will add u to both sides. If we add u to both sides, we have v is equal to u plus at. This is the first equation of motion. V is equal to u plus at is the first equation of motion. Now let's derive the second equation of motion. The second equation of motion is simply, this is the first equation of motion. The second equation of motion, is derived from the formula of average velocity. I think we know two formulas for average velocity. We are going to be using the two formulas that we know for average velocity. The first formula for average velocity is average velocity. Just like you want to find the average of two ages, like my age and yours, okay, you simply add the two ages and divide by 2. It's the same thing we are doing here. Final velocity plus initial velocity divided by 2, which is what? V plus u all over 2. This is the first formula. Okay, we'll be using the second formula that we also know, which is average velocity is equal to displacement over time. But let's deal with this first. So this is equal to what? V plus u all over 2. But we have derived the first equation of motion to be v is equal to u plus at. So if we substitute this v with u plus at, that means we are going to be replacing this v with what? U plus at. This v will be replaced with u plus at. This v will be replaced with first equation of motion. So it means we are going to be having our average velocity. Permit me to use this. Average velocity is going to be what? U plus at, okay, plus u plus another u all over 2. Is that okay? So if we combine these two, collect like terms, this will give us what? 2u plus 80 all over 2. Okay, now let's stop here for the first formula for average velocity. Now let's use the second formula. The second formula for average velocity is equal to what? Either displacement over time or distance over time. Let me use distance over time. This is the same thing as S over T. Okay? S over T. But now, this is average velocity. It means it's another formula for average velocity. Let's call this one equation 1. And let's call this one equation 2. Okay? Now, if we equate equation 1 and 2, equating equation 1 and 2, if we equate it, we have S all over T, this equation 2, equate it to this one, is equal to 2U plus AT all over 2. Okay? Now, if we break this one down, we have S all over T is equal to U plus what? Half AT. That's 2 divided by 2. We'll be left with U. Then 2 into this. Okay? Will give us half of it, which is 80 all over 2. Now, if we cross multiply from here, if we cross multiply, we have S is equal to T into what? U plus half AT. Let's open the bracket. If we open the bracket, we'll have S is equal to T times U. We'll have UT. T times this, we'll have what? Plus what? Half AT squared. This is the second equation of motion. S is equal to UT plus half AT squared. The third equation of motion. Now, we are going to derive the third equation of motion by squaring the first equation of motion. Okay? After squaring the first equation of motion, okay, we input S equal to UT plus half AT squared along the line. Let's see how we are going to achieve this. Okay? What is the first equation of motion? If you still remember, is equal to what? V is equal to U plus AT. So we are going to be squaring the both sides. Okay, so we have for third equation of motion, third equation of motion. So we have V is equal to U plus AT. So we are going to be squaring both sides, like I said. So we have V squared is equal to U plus AT all squared. So this is the same thing as V squared is equal to U plus AT, okay, squared, is equal, open bracket again, U plus what? AT. Okay, so let's do this. U times U will give us U squared. U times AT will give us what? Plus what? UAT. AT times U will give us plus what? UAT. Okay, ATU is multiplicative. ATU is the same thing as UAT. So we have UAT plus AT times AT. We have what? Plus what? A squared T squared. Is that okay? So now let's collect like them to give us this U squared plus what? UAT plus UAT is common. So we have what? 2UAT. We assume that this is 1UAT plus another 1UAT. 1 plus 1 will give us 2. So we have plus what? A squared T squared. So now we are going to kind of factor out 2A. Yeah, we'll factor out 2A from these two sides. So it becomes v square is equal to u square plus 2a, okay, all over 2a into 2u at plus a squared t squared. I've not done anything. This equation is the same thing with this. I've not done anything. 2a all over 2a is the same thing as 1. So 1 times this will still bring us back here. I haven't done anything. Okay, let's open the bracket. We have v square is equal to what? U square plus 2a into 2u t all over 2a plus a squared t squared all over 2a. Now let's do our division. 2 into this, it will go. A will cancel this one. You are left with what? ut. Okay? A will cancel a. You are left with 1a. So we have plus what? At squared all over 2. What does this look like? You still remember our second equation of motion we just derived? The second equation is what? Simply what? S is equal to what? Ut plus half at squared. So we are going to replace this with S. Since S is equal to ut plus half at squared. I hope you know that at squared all over 2 is the same thing as half at squared. It's the same. 1 times at squared, we are here, and then the 2 comes back. Okay, so since we understand that S is equal to ut plus half at squared, we can substitute S to replace the whole of this, and then we have what? V square is equal to what? U square plus 2as. And this is the third equation of motion. This is the third equation of motion. I know by now you should be able to do this on your own, where we have the first equation to be what? V is equal to U plus AT. The second equation to be what? S is equal to UT plus half AT squared. And the third equation to be what? V square is equal to what? U square plus 2as. So I would like us to solve simple problems on equations of motion. I have 2 examples on the board. Let's start with example 1. Example 1 says, a body accelerates uniformly from rest at the rate of 3 meters per second. Okay, it means from rest, it means the initial velocity is equal to 0 meters per second. Okay, at the rate of 3 meters per second, so it means the acceleration is equal to what? 3 meters per second squared for 8 seconds. So the time is 8 seconds. Calculate the distance covered by the body during acceleration. So we are looking for S. What formula do you think is appropriate for this question? We are looking for S. From the formulas or the equations of motion, we have V is equal to U plus AT. We have S is equal to UT plus half AT squared. And then we have V square is equal to U square plus 2AS. So which formula, which of the equation do you think is appropriate for this question? We are looking for distance. Of course, we know this is not applicable. We can't find distance using that. Okay, this can go, but which is going to be appropriate? Okay, I think this will be appropriate. Yeah, we have initial velocity, we have time, we have acceleration. So let's use the second equation of motion. So we have S is equal to UT plus half AT squared, which is equal to initial velocity 0 times the time is what? 8. Then we have plus what? Half times the A is what? 3 times time. What's time? Time is 8. So So we have 8 all squared. So of course this is going to tend to 0. So we are left with what? 1 over 2 times 3. 8 squared is what? 64. Okay. 2 here 1. 2 into this we have what? 32. 32 times 3 will give us what? 96. And what is the unit of distance? The unit of distance is meters. So we are going to be writing meters. I hope you know that in physics we don't joke with units. It is important that you write the unit of whatever quantity you have been asked to solve. So we are going to go into the example 2. We are going to solve example 2. So when you have a question like this, a particle accelerates. Example 2, please. Example 2. A particle accelerates uniformly from rest. So it means u is going to be 0. When you hear the word rest, you know it's starting from 0. At 6 meters per second square. So A is equal to what? 6 what? 0.0 meter per second square. Alone, in case you are confused of what the magnitude is referring to, or you are confused, just check out the unit. The unit will always give you the hint of what quantity it is representing. Okay? We know that meter per second square is acceleration. Okay? Now we have for 8 seconds. The time is what? 8 seconds. And then decelerate. You can see from this question we are having information of 2 kinds of motion for acceleration and deceleration. Okay, let me put the other part here. And then decelerate uniformly. Okay, negative acceleration to rest. So it means to rest, it decelerated from a particular velocity to rest. So it means the final velocity is equal to what? 0 meter per second. Okay? In the next 4 seconds. So the time it took for the deceleration is what? 4 seconds. Determine the magnitude. Determine the magnitude of the deceleration. So in this question we are looking for what? The deceleration. That's the negative acceleration is what we are asked to find. How do we do this? What formula do you think we should use to find the deceleration, since it's the deceleration we are looking for? Okay. From the equation of motion, we have v is equal to u plus at, we have s is equal to, all the equations can be used, okay, but which is easier? Let's check out the first equation of motion. V is equal to u plus at. We want to find the deceleration. This is it, okay. We can't find it. You know, we can't find 2 unknowns at the same time. We don't have the final velocity, so we can't solve this problem using this formula. However, we can find it using the first information given on acceleration. Okay, let's do this. So we have v is equal to u is what? 0 plus a is what? 6 times time. Time is what? 8. So we have v is equal to 6 times 8 is 46. I think we have 46 meters per second. 46 meters per second. So we have gotten our final velocity. We can use it to solve this problem. So v is equal to u plus 80. So, you know, for deceleration, it started decelerating from this velocity. So this is going to be the initial velocity, because it's from this velocity, it accelerated and attained a height, and then from that particular velocity, it started decelerating. So this is the what? Initial, and this is the what? Final. So we have 0 is equal to what? Initial velocity is what? 48, then plus what? A that we are looking for. A, negative acceleration. Please bear this in mind. Then we have our what? Time to be 4. So we have 0 is equal to 48 plus 4a. Okay, so if we usually I like if we take either of it to the other side, you have minus 48 is equal to what? 4a. Okay, so now we have 4a will become, divide both sides by 4, we have what? Minus 48 divided by 4. Okay, remember this is negative acceleration, so we have 4 divided by this, we have what? 4 into this, we have 1. 4 here, we have 2 meter per second squared. So this minus we cancel minus, we have our deceleration to be what? 12 meter per second squared. Please, if you have any question, please feel free to drop your questions in the comment section, and please don't forget to like and share. I'm still Bukola Joseph. Thank you very much.